Let's start with the example 2. Okay, the example 2 is like this. Now we have to calculate the convolution of two discrete signals given x of n is equal to u of n and h of n is equal to a of n u of n. The ROS is also given where it says mod a is less than 1 and also given is n is greater than or equal to 0. Now we have to do convolution. So basically to start this type of problems, what we have to do is first let us plot what is x of n and what is h of n. Now after plotting these two, we will write the formula for convolution, which is for a discrete time series. We know what is the formula, we will write down that and we will calculate for different values of n what is the convolved output. Like this we will see this, and finally we will draw the plot of the output result. So these are the various steps which we have to follow. So let us start with first plotting x of n and then later h of n. So let us see here, x of n is given as u of n. Okay, let us say this is my x of n. Okay, this is given as u of n. So what will happen here? It is at 0, this will have a value of 1. Okay, at 1 it will have again a value of 1. Okay, so it is and so on. So this is what is our n, this is our x of n. Similarly, I can also draw h of n. So what is h of n given as? H of n is given as a to the power of n u of n. That means again it is a right handed sequence. So let us draw for h of n also. Okay, this is my h of n 0. So a to the power of n, so this will be 1 here. Okay, then this will be a square, a cube, a to the power of 4, like that it can have different values. Okay, this is n. This is the fact why the figure is like this, because a is given as less than 1. So these are the values which you have plotted. Now these two signals have to be convolved. So how do you do the convolution? So let us say yn is the convolution of these two discrete signals. So what is yn given as? Yn is given as k is equal to minus infinity to plus infinity x of k h of n minus k, h of k and n minus k. This is one formula which we can use. Also x of n is given as u of n and h of n is this. So let us take, if h of n is the input, then h of n will be convolved with x of n. So I can also write this as equal to k is equal to minus infinity h of k and x of n minus k. So let us take this part here and then let us do this problem. Okay, keeping these points in view, let us say y of n is the convolved output, k is equal to minus infinity to plus infinity, h of k and x of n minus k. Okay, now we have to see what is y of n for different values of n. That is, if n is equal to 0, what is y of 0? If n is equal to 1, what is y of n? Like that we have to calculate different values of y of n, that will be the convolved output. So let us start with case 1. Let us say the case 1 is n is equal to 0. So what will y of 0 be equal to? Y of 0 will be equal to summation k is equal to minus infinity to plus infinity h of k x of, this is 0 now, 0 minus k. So this will be minus k. Okay, let us write down these values. So as this is a right handed sequence, I am starting from n is equal to 0. If there is a left hand also, there are some discrete points available, then we should start from that. Okay, so now we'll start, that's the reason why we are starting from n is equal to 0. Now what is the value of y of 0 now? Let us expand for different values of k. Let us take h of k is equal to 0, h of 0 plus x of 0 plus h of 0, x of 0 plus h of 1, okay, x of minus 1 plus h of 2, x of minus 2, okay, and so on. Why I am stopping here? Because x, whenever x is becoming negative, there are no values here. So even if I write up to n also, it doesn't exist. So we are stopping it at x of minus 2. just in case. Okay. Now, what is h of 0 here? If you look at this, h of 0 is having a value of 1. Okay, 1. What is x of 0? X of 0 is having a value of 1 here. So, I will put 1 here. Then, what is h of 1 for us here? H of 1 is a. So, let us write a here. And what is x of minus 1? X of minus 1 does not exist. That is, if I write here minus 1 and minus 2 here, they are all zeros. So, this will be 0. Similarly, h of 2 is how much? A square. So, this will be a square into 0 plus so on. So, in effect, this is equal to 1. Okay, let us write down this result here. So, y of 0 is equal to 1 here. Okay. Similarly, let us take up the second case. Now, let us see when n is equal to 1. Okay, we have already seen for n is equal to 0. So, let us see for n is equal to 1. So, what will be the value of that? So, that will be equal to y of 1. Okay, so, what is y of n? That will be summation k is equal to minus infinity to plus infinity h of k x of, what is n for us now? 1. So, it will be 1 minus k. Let us see now what is y of 1 here. Okay. Now, let us write down y of 1 is equal to, okay, what should be the value? First value, let us take k is equal to 0. So, h of 0, x of 1 minus 0 is 1, okay, plus h of 1, x of 0, okay, plus h of 2, x of minus 1 and so on. Okay. Now, let us see what is h of 0 for us. If you see, h of 0 is 1 for us here. So, that is 1. What is x of 1 here? It is again 1, plus what is h of 1 for us here? H of 1 is a here. So, let us put a here, and x of 0 is how much? 1 here, okay, and so on. But h of 2 is how much here? A square, but that is getting multiplied by x of minus 1. So, x of minus does not exist, that will be 0. So, let us put it 0. So, if you see here, this will be 1 plus a. So, let us write down here y of 1 is equal to 1 plus a, 1 plus a. Now, let us look at the third case where n is equal to 2. Okay, let us put down here n is equal to 2. So, what will be my y of 2 now? Y of 2 will be equal to k minus infinity to plus infinity h of k, okay, and x of 2 minus k, okay, because n is equal to 2 here. Now, let us write down this, expand this series. So, y of 2 is equal to, first of all, let us put k is equal to 0. So, h of 0, x of 2 minus 0, that will be 2, plus h of 1, x of 2 minus 1, that is 1, plus h of 2, x of 2 minus 2, 0, plus h of 3, x of minus 1 and so on. Okay. So, let us see this. Now, again we will go to this graph and find out what are the different values of h and what are the different values of x. Now, what is h of 0 for us now? As you are aware, h of 0 is 1. So, let us put 1 here, and x, whether it is 1, 2, 3, 4 up to n, its value is always 1. So, let us put here 1 here, as is seen from the graph also the same. Now, what is h of 1 for us? H of 1 for us is a. So, let us put a here and 1 here, plus h of 2 for us is how much? A square. So, a square into x of 0 is 1 plus a cube into 0. So, that will be 0. So, it will be 0 again. So, how much is this now? This will be 1 plus a square. So, this will be equal to 1 plus a square. So, let us write down this here. 2 is equal to 1 plus a square. Okay. If you look at the answer, there is a pattern that is emerging. Okay. So, let us take one more n value of n and see if really there exists a pattern. If you see here, it is 1 here first, then 1 plus a, then 1 plus a plus a square. If this continues, next must be 1 plus a square plus a cube. Let us confirm that and then we will stop there. Let us now take the case of n is equal to 3. That means I will get a value of y of 3, that is equal to, again, summation from k is equal to minus infinity to plus infinity, h of k into x of 3 minus k. 3 minus k. Okay. Now let us see y of 3 now. Y of 3 will be equal to, start with again 0, h of 0 into x of 3 here. Okay. Then comes h of 1, x of 2. So this is h of 0, x of 3 plus h of 1, x of 2 plus now h of 2 and x of 3 minus 2, that is 1, okay, plus h of 3, x of 0 plus h of 4, x of minus 1 and so on. Okay. Now let us see this. Now h of 0 is 1 for us here, and as I said, x of 3 up to n is always 1. So this is 1 plus h of 1 is a, and this is 1 plus h of 2 is a square, this is 1 plus this is a cube, okay, into 1 plus 0. So what is the answer now? This will be equal to 1 plus a square plus a cube. 1 plus a square plus a cube. So let us write down that here. So y of 3 is equal to 1 plus a square plus a cube and so on. Okay. So these are the different values. Now we can clearly see that there is a pattern that is coming. Okay. And in fact, when we calculate y of 4, it will be 1 plus a square plus a cube plus a to the power 4 and so on. So let us stop this, because this is an infinite sequence which is existing from 0 to infinity, and this is also infinite sequence exists from 0 to infinity. So we can actually generalize the whole thing. Let us generalize this. Note the two cases. Let us take first for n is greater than 0. So y of n will be how much? That will be equal to 1 plus a square plus a cube plus a4 plus so on. So this I can write as 1 by 1 minus a to the power of n plus 1 by 1 minus a. This is a progression which is happening, so we can write this formula. Now for n is equal to less than 0, y of n is 0. Okay. So this is how you can generalize the values. Now let us plot y of n. How do I plot y of n now? Okay, let us draw this here. Now let us, this is my y of n and this is our n. Okay. Now if I do the summation compulsorily, all the maximum value it can get is 1 by 1 minus a, where a is less than 1. Let us start with the first one. The first one will be, let us say this is 1 here. Okay. Then comes 1 plus a. Okay, what we will do is we will take this a little down, because we should see the plot clearly. So I repeat. So let us start with y is equal to 0, 1. So let us say 1 is somewhere here. So this is my 1. The second point is 1 plus a. So let us say this is somewhere here. This is 1 plus a plot for me. Then comes here 1 plus a square. Then comes here 1 plus a cube. Then 1 plus a square. Okay, sorry, this is a square plus a cube. I repeat. First of all, let us start with 1 here. This is y of 0 is 1. So the next one will be 1 plus a. So this is 1 plus a little greater than 1 plus a. So a small fraction greater than that. Then 1 plus a square little bit higher than this. 1 plus a square plus 1 plus a square. A plus a square, then 1 plus a square plus a cube, like that, so on. So if I join this curve, it will try to reach your maximum 1 by 1 minus a. This will be reached when your k is huge, that means it goes to infinity, or n goes to infinity, then this will be able to reach that point. So this is the convolution of two signals given here, u of n and h of n, and the convolved product will look like this. So this is your final answer. Let us start the example 3. Now, we have to compute the convolution of these two signals given here. Okay. So far the examples which you have seen are only a single sided sequences. We said no, this is existing from 0 to infinity, or whether it is from 0 to minus infinity, there is a single sequence. Now, if you look at this peculiarity of this particular problem is, there seems to be a range of values on either side of the axis. So, now for this type of problems, what we have to do is, for x of n and for h of n, we will separately find out what is the leftmost value and what is the rightmost value. Okay. We represent them as xl and xr. Similarly, for h of n, the leftmost value and the rightmost value, we call it as hl and hr. Now, when I convolve these two, what will be the leftmost value for y of n? That means y of l and then y of r. So, let us first do that. So, this will give us an idea from where we have to start computing the convolution. So, let us start with xl first. If you see here, xl, the leftmost value is 0. Okay. xr, what is xr? That is rightmost value is how much? 2. Similarly, hl, what is the leftmost value? Minus 1, and rightmost value is 2. Okay. So, this is how you find out what is the leftmost value and what is the rightmost value. Now, what is the leftmost value for the convolved product? This will be equal to xl plus hl, this will be equal to 0 minus 1, that is minus 1, that is 0 plus of minus 1, so it is minus 1. Similarly, what is y of r? Y of r will be 2 plus 2, that is 4. Now, what does this indicate? Now, if you look at the y here, y of l is minus 1 and y of r is 4. That means, the range of values which I should take is y will start from minus 1 and go up to plus 4. So, that is what are the values I should take now? Minus 1, 0, 1, 2, 3, 4. Then I will get the complete convolved product. So, let us start this. So, again we know the formula. What is the formula? Y of n is equal to summation k is equal to minus infinity to plus infinity x of k h of n minus k. Okay. Now, what should be the first value of n for us? It must be minus 1. Okay. And also there is another general method, if you can also look at this, is x of n does not exist for minus 1, but in fact for h of n this is there. So, we should start from n is equal to minus 1. So, let us start with case 1, n is equal to minus 1 first. So, what of y of minus 1 is equal to? This will be equal to summation k is equal to minus infinity to plus infinity x of k h of minus 1 minus k. So, this is minus 1, this is minus k. Okay, let us do this. Let us start again here. So, I will write down here minus 1 is equal to, first of all is x of 0 h of minus 1 minus 0. So, this will be minus 1, okay, plus x of 1 h of minus 2, x of 0 here h of minus 1 minus 0. So, it will be h of minus 1. Next is x of k is 1. So, x of 1 plus h of minus 1 minus of 1. So, h of minus 2 plus x of 2 here and h of minus 3 here plus, we can go actually, but x of 3 there does not exist anything. So, we can stop it here. Okay. So, how much is this? Now, what is x of 0 for us? X of 0 is how much? 1 here. So, that is 1, and what is h of minus 1? H of minus 1 is again 1. So, this will be 1 plus x of 1 is how much for us? X of 1 is for us 2 here. So, this I can write as 2, and h of minus 2 is not existing. So, this will become 0. Okay. plus how much is x of 2 for us? X of 2 for us is 3. So, this I can write as 3, okay, and h of minus 3 it is not existing. So, this will become 0. So, finally, this is equal to 1. So, y of minus 1 is equal to 1. Okay. So, this is y of minus 1 is equal to minus 1. So, let us write down this value somewhere here for further reference. So, I can write down here. So, y of minus 1 is equal to 1 for us. Let us now take up the second case, which is now n will be equal to 0. Now, let us take up the case here. Okay. What is the case here? N is equal to 0. Let us start with n is equal to 0. So, y of 0 will be how much? Y of 0 will be equal to summation k is equal to minus infinity to plus infinity x of k h of minus k, because n is 0 it will be minus k. Now, let us do this for different cases. So, y of 0 is equal to for different values of k. Let us start with 0, x of 0. You have to remember one point here. There seems to be some values which are existing even below this, isn't it? So, let us decide whether we should take it here from minus 1 or let us take it from 0. So, there is no harm, because we are starting from minus 1, let us put minus 1 here first and then we will go ahead. Okay. But another point you should remember here is minus 1 h, this is existing whereas this does not exist. So, there is no point in starting from minus into plus infinity. If this common for both of them, then I can actually start from those values. So, there is nothing wrong if I start with x of 0, because of our general understanding looking at the figures, we say we can start with 0, because even if I take this minus 1, h of minus 1 does exist, but x of minus 1 does not exist. So, let us start with 0. So, how much is this? This is also 0 plus x of 1 h of minus 1 plus x of 2 h of minus 2 plus so on. Okay. I am stopping because x of 2 is there here, final value. So, what is this x of 0 for us? X of 0 for us is 1 here, h of 0 is how much? 2 here, plus what is x of 1 for us here? X of 1 for us is 2 here, h of minus 1 is 1 here, okay, and x of 2 there is a value that is 3, but h of minus 2 there is nothing. So, that will be 0. Okay. So, this will be 3 into 0. So, what I get is 2 plus 2, that is equal to 4. So, let us write down here y of 0 is equal to 4. This is the second case. Now, on similar lines, y of minus 1 has been calculated, is found to be equal to 1, y of 0 is found to be 4, y of 1 is calculated to be 5, y of 2 is calculated to be 1, and y of 3 is calculated to be minus 8, and y of 4 is calculated to be minus 3. Now, let us plot this. Okay. On similar lines, we have calculated all this. Now, if you look at y, the lowest range is minus 1. So, this is going to be our YL, and what is YR? 4. So, this will be my YR. So, the range has been satisfied. Now, let us plot them. Let us plot this. This is our y of n. Okay. So, this is our 0 and this is our minus 1, okay, because we started from minus 1. What is the value of minus 1? It is 1 here. So, you can write down here, okay, this is my value of 1 here. Y of 0 is 4. So, y of 0 will be 4 here, okay. Then y of 1 is 5. So, let us take this as 1. So, this will be somewhere here. So, this is my value y of n. Then y of 2 is again 1. So, this is 1, this is 2, y of 2 is 1 here, okay. Y of 3 is minus 8. So, this is 3. So, this will go here. So, this, let us say this is not drawn to scale. So, this is minus 8, this is not drawn to scale, please remember that. Then y of 4 is minus 3. So, this is 4 and this is around minus 3 here. Okay. So, like this is the convolution of the given signals.